Hello my dear students, welcome back to the session. Now let's look at 11th problem which was asked in GATE. It was asked in GATE. Go through the 11th problem. Find the ratio of V2 to V1. Yes or no? That's the question. Here Y parameters are given. 1 by 10 minus 1 by 100, 1 by 100, 1 by 10. This is the values given. All are in Siemens definitely. And the load is given here 100 ohm. Right? Okay. So he defined already this is V1 and this is I1. This is I2 and this is V2. So now he's asking what is V2 by V1. This was asked in GATE. Okay. You can try. Meanwhile, I just take another problem. 12th problem. V2 by Vs. 12th problem. You can try. You can make an attempt. This is V2 given. You can make an attempt. That problem, all of you. You can try. This is I1. This is I2. Okay, similar procedure, no doubt. Now here Y matrix is given, Y parameters are given for this throughput network. First you write the equations. I1 is equal to Y11 V1 plus Y12 V2. See the calculation part I'm not doing on the board. Okay, it takes time. You can try. You must be good at calculation part. Okay, I can directly give you the answer. I'll explain you how to write the equation and what equations you get. You just substitute the values and get the answers. Okay. And I2 is equal to Y21 V1 plus Y22 V2. Equation 2. I will get V2 is equal to. Can I write minus 100 I2? I hope you understand this. Why minus? Because this current will give you the polarities. This is plus, this is minus. But you want with reverse. Mismatch is there. Again, V1 is equal to 100 minus 25 I1. That's it. That's it. V2 by V1 is asking. Okay, is asking V2 by V1. So substitute this V2 in both the equations. But V2 will be eliminated. Don't substitute that. I2 you substitute here. I2 is equal to minus V2 by 100. And I1 you substitute here from this. Nothing but 100 minus V1 by 25. So from this you get I2 is equal to minus V2 by 100. Still you call it equation 3 only. Because just we are rewriting the equations. I1 can be 100 minus V1 by 25. This is equation 4. Now if you substitute this 4 and 3. So substitute 4 in 1. You will get directly. So you will directly get that from that. I2, you don't need to deal with all these equations. or else you can directly go with equation 3. What is equation 3? Deals with I2. So substitute 3 into that directly. Okay, 3 into. So if you substitute 3 into, this I2 got eliminated. Entire equation is in terms of V1, V2 only. Yes or no? So minus V2 by 100 is equal to Y21 V1 plus Y22 V2. That's it. So you take V2 common. What is V2 common here? If it goes like this, or if it is taken like this, yeah, you take that side otherwise. So what do you get here? What do you get here? Y22 plus 1 by 100 is equal to minus Y21 V1. You want V2 by V1. This is what the ratio asked, yes or no? So minus Y21 by Y22 plus 1 by 100. What is Y21 given here? Y21 is given as minus 1 by 100. Okay, already minus sign, Y21. What is Y22 is given? 1 by 10 plus 1 by 100. So you will get the value. Yes or no? Okay, so what do you get here? So you will get the 100 get cancelled, but 10 here, 100 plus 10. So 110. Yes or no? 110. So and you will get 100 cancel, and 10 by minus 10 by 110. So finally you will get, okay, minus 1 by 11. That's it. Minus 1 by 11. That's it. You got the answer. A simple mechanism. Only thing you have to identify the equations and then what exactly your objective. Simplify that easily. Solve the problem V2 by Vs. You can proceed in the similar way. Coming to the 12th problem, you see he is asking V2 by Vs. Vs and this is V2. The ratio is asking. Just like in the previous case, but only difference is what? Here the two-port networks are presented which are connected in series. One two-port network is described by Z parameters. The other two-port network we do not know, but we can find the values. Yes or no? So when two-port networks are connected in series, which parameters are more suitable to deal with? You already know the resultant of the two-port networks when they are connected in series. The resulting Z is nothing but sum of individual Z matrices. Here luckily Z matrix is given. If it is not Z matrix, then you are supposed to find Z matrix for that. Because when you know Zx and Zy, X network and Y network, Zx and Zy matrices, then only it is possible to find the overall Z. Yes or no? Luckily here Z is given. You can also find Z of this, because this is also just like a T model. But here 0 ohm, here also 0 ohm, 0, ZA, ZB, ZC. So this is one two-port network, a T model. So Zx is known here, already Zx is known, okay, or this is Zy, let us say. What is Zy? 0 plus 10, that is 10, and 0 plus 10, again 10, 10, 10, and 10. What is Zx already given? 12, 8, 8, 20 is already given. So what is the overall Z matrix? Tell me. Overall Z matrix is Zx plus Zy. Okay. Right. So what do you get here? If you add 22, 18, 18, 30. Yes or no? So now you can replace this whole two-port network by a single two-port network whose parameters are 22, 18, 18, 30. Yes or no? Now you just get the equation just like in the previous. So V1 is equal to 22I1 plus 18I2, equation 1. V2 is equal to 18I1 plus 30I2. Yes or no? And V1 is equal to Vs minus 5I1. And V2 is equal to, you get that, minus 20I2. That's it. Fourth. You want V2 by Vs. For V2 by Vs, you need to eliminate V1 and I1 and I2. There are 5 variables but 4 equations. Okay? It's possible to find the ratio. It may not be possible to find the exact values of V2 and Vs because number of variables and number of equations, there is a mismatch. Number of equations are less than number of variables. It's not possible to find the values, but it is possible to express V2 in terms of Vs or Vs in terms of V2. Okay? So from this, you eliminate V1 first. V1 is substituted here, and V2 is substituted here. No, here you can't substitute V2 because V2 is required. You can't eliminate V2, but I2 can be eliminated. And from that, you can get V2 by Vs. So from this fourth equation, I can write V2 is equal to minus V2 by 20. You still call it 4 only. So substitute 4 in 2. You will get entire equation. You will get entire equation. That is I1 is equal to something into V2. Call it 5. Substitute 3 in 1. You will eliminate V1 and entire equation will be in terms of Vs, I1, I2. Okay, so you should also substitute this 4 in 1, okay, and 4 in 1. Then I2 is also eliminated. So entire equation you will see here. So you will get when 4 is substituted in 1, then I2 eliminated. 3 is substituted in 1, V1 is eliminated. So I2 is eliminated, V1 is eliminated. What are left over? I1 and Vs. So you will get I1 is equal to something into, because this is substituted here. So in terms of Vs. Now I guess you understand. If 5 is substituted in 6, then you will get V2 is equal to something into Vs. So this is what required. Okay, I give that answer directly here, 0.3509. Okay, from this you understand V2 by Vs, 0.3509. Please note down. So this is X two-port network and this is Y two-port network. You found ZX and ZY. ZY is very clearly mentioned. Okay, adding these two, and this is Z12 and Z21. That's why you got 10, 10, 10, 10. I just give meanwhile another problem, 13th one. Okay. Find Z parameters. You please quickly complete that. This is 1 ohm, 1 ohm, 2 ohm, 2 ohm, 2 ohm, 4 ohm. Find the Z matrix. Okay, you can find Z matrix of the given two-port network. How do you solve this two-port network? I mean, to find the parameters. Okay, you can understand by looking at this particular two-port network. Here is one T and another T. Both are connected in parallel. I hope you realize that they are in parallel. You observe that they are in parallel. If you can identify that, the problem will become easy. Okay, if you don't realize that they are not in parallel, I'll prove it again here. This is only to prove, to make you understand. But in exam, you must understand when the problem is given. In the first glance itself, we must identify that they are in parallel. That's it, okay? So let me just take like this. This is 1, 1 dash, 2, 2 dash. Two different methods I can apply. First method I will take, okay, that they are in parallel. So let me prove it. This is 1, 1 dash. This is 2, 2 dash. 1, 1 dash, another network, 2, 2 dash. This is another two-port network. The first two-port network, I would like to take 1, 1, 2. Okay. So 1, 1 is connected between 1 and 2, right? So this is how. And 1 dash and 2 dash are shorted. Here also it is shorted. Between these two, you got 1 ohm, 1 ohm. This is 2 ohm. Similarly, you got, right? So between 1 and 2, there is another branch connected here. The other two-port network I am taking. 2 ohm, 2 ohm. And in the mid of this, you connected between these 2 points. 4 ohm. But already this 2 is connected to 1. That means this 1 and 2 must be connected. So let me take here like this. They are connected. Okay. Already 1 dash, 2 dash and 1 dash, 2 dash are zero potential. So let me take. So finally this is 1, 1 dash. Similarly, this 2 and 1 are connected. Therefore, this 1 and 2 are connected. So anyway, this 2 dash and 2 dash are connected. Now these two-port networks are connected in parallel. If I can replace these two by a single using our methodology, Y is nothing but sum of individual Y matrices. Remember, when two-port networks are connected in parallel, which parameters are more suitable to deal with? Y parameters, right? But T models are given. For T models, which parameters are more suitable to deal with? For T model, which parameters are more easy to determine? Z parameters. Actually, I want Yx and Yy. But looking at this scenario, I understand that it is easy to find Zx and Zy. But I want Yx and Yy. If you know Zx, can't you find Yx? You can. Therefore,